Dear friends, today in this lecture we will discuss about electrostatic force, or it is also called Coulomb's force. First, let us discuss today what is force. You have read in class 9th, you have read in class 11th. What is force? If I ask you this question, you will tell me the traditional definition. Force is an external agent which creates motion, destroys motion, like this you will tell, etc. But I will tell you one thing. Force is God in physics. What is the role played by God in your real life? That is the role played by actually force. If you ask me how, I'll tell you. You are telling force is the creator, force creates motion. So who is the creator? Lord Brahma is the creator. Force destroys motion. Who is the destroyer? Lord Maheshwar is the destroyer. Also force maintain motion. So who maintain the whole world? Lord Vishnu maintain the whole world. So force is Lord Brahma, force is Lord Vishnu, force is Lord Maheshwar. So I will tell you force. Another thing also I can tell you. Have you seen God? You will tell, no, I have not seen. Have you seen force? Same thing. You have also not seen force. Have you realized God? Yes. You will tell, yes, I have realized God in many more times. God has helped me from very bad situation. I relief from very bad situations. I realized God. Have you realized force? Yes. If you have not realized, if I will give you a slap, then you can able to realize force. You will realize, but you can't able to see what is force. Okay, so if I tell you the definition of professors in higher classes, what definition we generally use for force? Force is the agent which is responsible for all changes in the universe. Just like you are telling, God is responsible for all changes in the universe. So you can tell this definition also. Force is an agent which is responsible for all changes in the universe. Okay, so you have read in class 11th. Forces are of There are 4 fundamental forces. I am just reminding you. First, gravitational force, then electromagnetic force, strong nuclear force, then weak force. 4 fundamental forces. But in class 11th, you have already read gravitational force, the weakest force. You have already read. Today, I am going to discuss that from the electromagnetic force. Today I will discuss only electrostatic force. That electromagnetic means it is a combination of electric force as well as magnetic force. But today we will discuss only electric force. So what is this electric force? You have read in class 11, gravitational force acts between dash. Okay, you are thinking the answer acts between 2 masses. That's good. Just like that, electrostatic force exists between 2 charges. You also know in lower classes this one. Between 2 charges, electrostatic force acts. When 2 charges are there, they can attract each other or they can repel each other. Unlike gravitational. But what happened in gravitational? In gravitational, only 2 masses can attract each other. But in electrostatic force, it can be attractive, it can be repulsive. You can keep a note. This is a difference between gravitational force and electrostatic force. Okay, today we will go to the mathematical expression. What scientist Coulomb, one scientist gave the law. Here, Coulomb's law, to know the magnitude of force between 2 charged particles. I am telling you, between 2 point charged particles. Only point. Point means, if the dimension of the charged particle is very small in comparison to the distance of observation. If you are calculating force between two charges you are calculating Q1 and Q2. The separation between them is R. These two charges will be treated as a point if magnitude of R is very large in comparison to the size of the charges Q1 and Q2. Then only they are treated as point charges. And Coulomb's law is only valid for point charges. Okay, I am telling you, suppose this is a charge body. Charge can also distribute on a rod. This is a charge body, and this total charge present in the charge body is Q1. This is a charge body point, it's Q2. If I will tell you to apply the force between these two, you cannot use Coulomb's law. Before telling what is Coulomb's law, I am just giving you the important information. This is very important. Don't use in this cases Coulomb's law. Coulomb's law is only valid for 2 point charges, means the distance is very large in comparison to the dimension of the charge. Okay. So what is the statement of Coulomb's law? Let's come to that. Statement of Coulomb's law. You have read the statement of Newton's law of gravitation. In gravitation, Newton gave the law. The great scientist. You must have remembered the law of Newton. If I ask you this, I hope you can able to tell the statement of Newton's law. Still, I am reminding you, the gravitational force between two point masses is directly proportional to product of their masses and inversely proportional to square of distance of separation between them and acts along the line joining the two masses. Similarly, Coulomb's law statement is also just copy paste. Same thing, only you change in Newton's law of gravitation, only you change the mass to charge. This is sufficient. Then now you can tell me, now you are thinking what is the statement of Coulomb's law? The electrostatic force between two point charges or between two point charge bodies, between two point charges, it's okay, is directly proportional to product of magnitude of charges and inversely proportional to square of distance of separation between them and acts along the line joining the two charges. So this is the statement of Coulomb's law. You can note this statement. So now you come to this mathematical expression. This is Q1, Q2. Separation is R. What Coulomb told in the law? F proportional to Q1, Q2. Product of magnitude of the charges. And inversely proportional to square of distance of separation between the two charges. If you combine them, then I will get F directly proportional to Q1, Q2 by R square. Now multiply one constant here, the constant is K. K Q1, Q2 by R square. So this is the Coulomb's law expression. But now the question comes here, what is this K? In Newton's law of gravitation, what was the constant? Capital G. But here, what is the constant? K. So the capital G, it had a fixed value. It has a fixed value, universal gravitational constant, but the problem is in K here. This K is called proportionality constant. And this K little vary. It depends on the system of unit taken, which system you are using, whether you are using SI or CGS. depending on the system of unit, this K value will vary. Also this K depends on medium between two charges. This one is another difference between gravitational force and electrostatic force. In gravitational force, medium doesn't matter. Whatever medium may be there, capital G is constant, mass is constant, distance constant, medium doesn't matter in gravitational force. But in electrostatic force, this K rigorously vary with the medium. If between two charges medium will change, then this value of K will change. Medium plays a vital role in electrostatic force. This is another difference between gravitational force and electrostatic force. Gravitational force is medium independent, but electrostatic force is medium dependent, which lies within this K. Now let's come and discuss about this K. What is actually this K? We'll elaborately discuss about this proportionality constant. So first come, I told you K varies with medium as well as varies with system of unit taken. Let us choose medium as air medium. You can take air medium, also you can take that as free space, or you can choose also that as vacuum. Almost free space, vacuum, both are same thing, but air is almost nearly equal to them, almost very close. So I have taken first medium is air or vacuum or space. What is the expression for vacuum? The same will be for air, little difference. Okay, so this is first we'll take the medium between two charges as air. Q1, this is Q2, separation is R. Take the medium as air or free space or vacuum. So now what will be, first take SI unit, because also K value with unit, for which I took now then unit, SI unit. If SI unit, then value of K is 1 by 4 pi epsilon naught. 1 by 4 pi epsilon naught. This is the new quantity now. This is a new quantity you are listening today. This is a new one, epsilon it is called. I will elaborately discuss about this epsilon. So 1 by 4 pi epsilon naught, its value is 9 into 10 to the power 9. 9 into 10 to the power 9, if from the formula if we bring the unit, it will be Newton into meter square by Coulomb square. Newton into meter square divided by Coulomb square. So this is the proportionality constant 1 by 4 pi epsilon naught. You can write the expression of force F, then F is, in place of K I am writing 1 by 4 pi epsilon naught Q1 Q2 by R square. So this is the expression of force. This is the expression of force when the medium is air or vacuum and the system is SI, the expression of force or Coulomb's law expression. Now I think it is coming the doubt to you, what is actually this epsilon? Let me discuss about that epsilon first, then we will proceed further. Epsilon is a constant for different medium, its value is fixed. Then what is the role of that epsilon? I am reminding you, in class, lower classes, class 9th or 8th somehow, you have read one constant called density. It varies from substance to substance. Density you have read. Why you have read density? What is the advantage of reading density? After reading density, you could able to gather the information whether that substance will sink in water or will float on water, and many more things, which one is heavy, which one is light, many more things you could able to gather from the information of density. But knowing the density, just like density for different medium, Just like density is a constant for different medium, for different substance it varies. This epsilon is just like the density is also one constant. Just you see I am zooming this epsilon. This also is a constant for different medium. But what is the role of this constant here? Epsilon, why will read? Just before I told you, electrostatic force depends on medium. If between two charges you keep air, suppose you keep air, if the force is 800 Newton between two charges. Now between the same two charges, keeping the distance fixed, you put some water. If you put some water there, immediately your force will be 10 Newton only. What happened? That means medium is playing a vital role. So when air is there, 800 Newton, when you put water, it will be only 10 Newton. If you take some other medium like paper, cement, mica, then also force will be different. Means medium playing a vital role here. But different medium playing different role. They are doing some interaction. When two charges are there, medium will keep. Means medium show some interaction and do something there. To know which medium show how much interaction, which medium show how much role, we have assigned one constant to different medium. What is that constant? Epsilon. Epsilon will give you the information, the role of the medium in electrostatic force. What role the medium plays? This is the epsilon. Just I am reminding you, we have read a density there for different medium. Here also the constant is epsilon for different medium, to know the role of the medium in electrostatic force. Another thing I am telling you, after knowing the density, it was not sufficient at that time. You have read another quantity related to that. I am reminding you another quantity. You have read density in the lower classes. But it was not sufficient, you have read another quantity there. What was that quantity? Relative density. Relative density, or that was also called specific gravity. How the relative density was written? What is the expression of relative density? Relative density is density of the body by density of the medium divided by density of water. You have compared everything with the density of water. Water is taken as a standard while reading density. And this, from the relative density expression, you can gather the information more easily whether the body will sink in water or will float in water. If it is greater than 1, it will, it will sink. It will be less than 1, it will float, is equal to 1, submerged condition, just like ice in water, what happened? Many information it gives you. And the density of water is taken as standard. Water is taken as standard substance while reading density. So while reading permittivity, which one is taken as standard? So here air is taken as standard medium. Just like water there, who play the main role here in permittivity? Electric permittivity? Air. So for air or for vacuum, we are denoting a special symbol epsilon naught. Not like this around it. So this is epsilon naught. Epsilon is for all the mediums. But if naught will be there, this symbol, this is only for vacuum. This is for all in general. But if naught is there, only for vacuum, only for air. And here, how you have find the relative density, the same thing also you will find here. Relative density, relative electric permittivity. So that is epsilon r. Relative permittivity. This is. It is also more important than this permittivity. It gives more information than permittivity, epsilon r. And the epsilon r, what is the formula? Just compare to that. Okay, I know you are already comparing. This is the relative permittivity of any medium. We will find how? Epsilon by epsilon naught. You just compare these two formulas, you can able to easily understand. It will not be new for you. now you can able to understand if you compare these two. You have done already in class 9th all these things. Just like relative density, relative electric permittivity. Density by density of water, permittivity by permittivity of vacuum. So this is relative electric permittivity. And it has more role than this. Always you will use this one. Relative electric permittivity. It has also another name. It is most commonly called as dielectric constant. Dielectric constant, what is the symbol is K. I can write small k, sometimes some are telling also this kappa. So it has 3 names and 2 symbols. Don't be confused about that. 3 names and 2 symbols. 2 symbols K or epsilon r. 3 names: relative electric permittivity, dielectric constant, and I will not tell the third one. That is the homework for you. You will search the book. What is the third name of this? I am just making you to read, to open the books to see, but don't search in internet. Time and again I am telling this thing to you. Okay, so this is about the dielectric constant or electric permittivity. Now I think you are clear about what is permittivity. Just like density, permittivity is also constant. Permittivity decides which medium has how much role in electrostatic force. Here water density is taken as a standard, but here air permittivity is taken as a standard. And what is the value of water density? You must have remembered the density of water. Everybody remember that one, 1 gram per cc. Just like this value also you can remember. At least one value you can remember. You have remembered water density. You can remember permittivity of a vacuum. It is also called absolute electric permittivity. 8.854 into 10 to the power minus 12. 8.854 into 10 to the power minus 12. And unit will be just reverse of K. Coulomb square by Newton into meter square. Epsilon naught value. If you put this epsilon naught value where? Here you see 1 by 4 pi epsilon naught 8.854 10 to the power minus 12 will put here, you will get 9 Newton per 9. If you don't believe me, then you can try in calculator. Then see, it will come 9 Newton per 9. This value is more important. 9 into 10 to the power 9. Okay, so I told you about this permittivity. Then we will go to the, we keep this one, it will be required for us. Now you see. So this is the force formula in SI system and air. If we come to the CGS system, what will the formula of force? This value of K in CGS become 1 when it is SI system. So what will the K means? This K I am telling you proportionality constant, which is in the Coulomb's law first formula. But this K I am telling you, this is dielectric constant. Dielectric constant or relative electric permittivity. Please be don't confuse about this, or I am making this K like this. Dielectric constant. So now this proportionality constant K is 1. So what is the formula? Coulomb's law formula now what becomes? Q1 Q2 by R square. So this is the formula in CGS system. When the medium is air. Now you go, if the medium is not air, if some other medium, some dielectric medium. What is dielectric? Again another new word is coming to you. Dielectric. Dielectric, for now I am telling you, it's just like insulator. Insulator is called dielectric, but not exactly same. But now you remember this one. But at the end of the second chapter, in polarization, it will be taught to you what is exactly dielectric, what is insulator. But insulator and dielectric, they are almost same. So just keep in mind insulator or some dielectric. So if some dielectric there, then what happen here? We come to the medium dielectric now. Dielectric medium. If dielectric medium, what is the value of K now? 1 by 4 pi epsilon. You may ask me, sir, why you are not writing naught? Because I have told you epsilon naught only stands for air, but for any other medium or general it is 4 by epsilon. But epsilon than epsilon, this quantity is more important. So now you bring the formula of epsilon from here. Epsilon becomes epsilon naught into epsilon r or epsilon naught into k. But most commonly used is the k. So I am writing k here. So 1 by 4 pi epsilon naught k. This is very problematic. So k small k. Okay. So what about the force now? You remember this one. 1 by 4 pi epsilon naught k q1 q2 by r square. You remember this is for when the medium is dielectric. I forgot this is SI system. In SI system, medium is dielectric. Then this is the formula of force. If I just add this k, then this will be for air. If k is there, then this is for medium. Only difference is now you can able to mark. While air 1 by 4 pi epsilon naught. While medium 1 by 4 pi epsilon naught k. Okay, then you come to CGS system. CGS. In CGS what happens? The value of k, you would come to this. I told you when CGS comes, then this much becomes 1. All these are experimental. All these are experimental laws. So don't ask me why this happens. 1 by 4 pi epsilon naught becomes 1. So if it becomes 1, what is the value of this? The value of this capital K is equal to 1 by small k. So now this will be 1 by small k q1 q2 by r square. When the medium is dielectric and the system is CGS, unit system is CGS. I think you got the information now here about the Coulomb's law. How many formulas you got here? 4 formulas. But in Newton's law of gravitation, how many formulas were there? Only 1 formula. That was very easy in comparison to this. So that's why that was in class 11th. Now this is in class 12th. So again I am telling you. So you can summarize here 4 formulas we got. In when, again I am repeating, when the medium is, again I am repeating, I am writing the 4 formulas you see. Air, medium, but system SI. So formula is 1 by 4 pi epsilon naught q1 q2 by r square. But if the medium is dielectric, then it becomes F equal to 1 by 4 pi epsilon naught k q1 q2 by r square. This k is dielectric constant, and in CGS F equal to q1 q2 by r square, and here it becomes 1 by k q1 q2 by r square. Again I am telling this k is dielectric constant, not proportionality constant. So this is about the Coulomb's force in electrostatics. Now we come to the point about this epsilon and epsilon r. I want to tell you some more things here. So this epsilon, I am giving you some questions here. About epsilon, you can find sometimes as a dimension comes in exams. This is a question to you. To find the dimension of epsilon. Epsilon and epsilon naught both are same. This is only for air, this is for null. So you can find the dimension of epsilon. This is my question to you. You try dimension of epsilon. And what is the dimension of epsilon r? I think in this answer you already got to sing this formula. But still this is the question to you. What is the dimensional formula of a dielectric constant or epsilon r? What is the unit of dielectric constant and epsilon r? This is also the question. And what is the unit of epsilon? Another question also I am asking you. What is the dielectric constant for vacuum? Clearly see this formula, you will get the answer. What is the dielectric constant for vacuum? Another information also, you search the book. What is the dielectric constant of metal? It's important. Metal plays a vital role in electric sector. What is the dielectric constant of metal? These are the questions I am giving you. You search the books and try to find. So this is about the Coulomb's law, but this is the Coulomb's law in scalar form. I wrote it big where there are force, but only magnitude, scalar form. So now I'll discuss again the Coulomb's law in vector form here. Vector form of Coulomb's law. Vector form of Coulomb's law. Now see what happens in vector form. Take two charges, Q1, one charge is Q2. So this Q1 charge, its position is R1. For this position vector you know R1. Its position vector is R2. And from Q1 to Q2, Q1 to Q2, so this is a line. This is called, you can tell it as displacement vector or something, no problem. Q1 to Q2, this is taken as R12 vector. Similarly, if I take Q2 to Q1, this will be taken as R12 vector. Now can you tell me R12 and R21 vector about them? What are they? Okay, they are just negative vectors. So I can write here R12 vector is minus R21 vector. Or same thing now from 11th class knowledge, both are same in magnitude, but the directions are opposite. R12 cap minus R21 cap. Cap you know, this represents direction. You have read in class 11th in vector. If you forgot, then you can see your 11th class copy and can refresh your brain about this. Okay. So now let us write what is the force expressed by Q1 due to Q2. F12 vector. We'll write the force expressed by Q1 due to Q2. So what is the force here? K. I am writing simple K here. Proportionality constant. According to the medium, according to the unit system, you will change the value of K. K Q1 Q2 R12 square. R12 square, then R12 cap. You will write it like this. What happened? This much is the magnitude and this represents the direction. The direction of the force this represents. You can tell me, sir, how you know the direction? Because you don't know the sign of the charges, whether they are taken positive or they are taken negative. You can take them plus plus, you can take them plus minus, you can take them minus plus like this. But I am writing simply this one. According to the magnitude of charges, you will know the direction at that time. But just I am writing in symbol these things. If both will be positive, then on Q1 force will be in this direction. If both will be positive, force will be in this direction. But if this is negative and this is positive, if this is negative and this is positive, then force will act in this direction. Just I have taken this symbol R12 vector. Don't be confused whether I will take R12 or R21 here, but like this. Oh, this is the mistake I have done here. R21 vector. This is R21 or R12. But now I think my expression will fit if this Q1 will be negative and this Q2 will be positive. So Q2 attack Q1 along R12 vector. I have done this to just keep it will be easy for you to remember. So K, this K Q1 Q2 R12 square. What about this cap? You know, vector by vector magnitude. You have read in vector chapter. Cap is equal to vector by vector magnitude. So K Q1 Q2 by R12. This is also magnitude square. This is magnitude. It becomes Q R12 vector. This is the vector form of Coulomb's law. If you want to extend it more, it will be K Q1 Q2 R12 vector. What will do here? You see R12 vector. I can write if you use your formula. So this vector plus this vector, triangular, if you use this vector plus this vector is equal to this vector. Or I can say R12 vector equal to R2 vector minus R1 vector. You see R12 vector, this plus this is equal to this. Then this is equal to R2 vector minus R1 vector. I can write it like this: R2 vector minus R1 vector mod q into R2 vector minus R1 vector. This is also the vector form, and it will help you to solve numericals. If the charges position will be given, then you can write R1 vector, R2 vector, you can find the magnitude, you can use this to solve the numericals. So this is the Coulomb's law in vector form when force on Q1 due to Q2. Now see, I am writing the expression when force acts on Q2 due to Q1. You see what will happen. Force acts on Q2 due to Q1. F21 vector K Q1 Q2 R21 square R21 cap on Q2 force act due to Q1. Now you see what happened here. K Q1 Q2 R, same thing if you proceed, then it will be R21 cube into R21 vector. 21 cube or mod cube you can write here, no problem. Now let us change it. Q1 Q2 R21 vector, you replace it R12 vector, because mod doesn't matter. Mod doesn't matter, both are same. So mod cube. But R21 vector I can reply it R12 vector. If I write, I have to put a minus sign. You see this expression? Then minus come outside. K Q1 Q2 R12 vector mod cube into R12 vector. So it become, this is the expression you can see, F12 vector. So F21 vector is equal to minus of F12 vector. So what is your confusion now? How much force Q1 experienced due to Q2? The same force Q2 experienced due to Q1. So they are equal in magnitude but opposite in direction, just like gravitational force. So in one sentence I can say electrostatic force between two charged particles is a mutual force. It's a mutual force. In exam the question may come, prove that electrostatic force between two charged particles is a mutual force. Actually we can say also here, does it satisfy Newton's third law? Action and reaction. Yes, this also satisfies Newton's third law. On Q1, Q2 apply force. Similarly, on Q2 immediately Q1 apply the force. It also satisfies Newton's third law, you see. In exam question will come, prove that Coulomb's law or electrostatic force between two point charged particles satisfy Newton's third law or obey Newton's third law. Now you see. You can fail. You can find one derivation of 2 marks like this. They satisfy. Prove that they satisfy Newton's third law. You have to prove this much. How much I have done in this vector form. This much you have to do. So this is about vector form of Coulomb's law. Now we come. What are the important points about this Coulomb's force? Some points I want to discuss. You some information about Coulomb's force. I told you one point. Already I have told. Already some points I have told you. It may be attractive or repulsive, unlike gravitational force. Second point, it is a central force, acts from center to center, so it is called central force, like also gravitational force, like gravitational force. Third is, it is a long range force. Long range. It becomes zero when the two charges become infinite distance apart. Then only it will be zero. It's a long range force. It is like gravitational force. Number 4, it depends on medium. This is unlike gravitational force. But it depends on medium. Then number 5, it is a mutual force. Gravitational force, electrostatic force is a mutual force. This is also like gravitational force. Point number 6, important, field particle. What is the field particle here? In electrostatic force, what is the field particle? Okay, some of you are thinking the answer electron. It's not electron. Field particle is photon. Field particle is photon. What was the field particle in gravitational force? Graviton. And here the field particle is photon. You know field particle you have read in class 11th in the first chapter physical world. A particle exchange happens between two bodies. Only due to that force exists between two bodies. Maybe gravitational, maybe electromagnetic, maybe strong nuclear, maybe weak force. All the region of force is exchange of a particle, and the particle is called as field particle. So the field particle here is photon. The exchange of photon always happens between two charged bodies due to what? The force acts between two charged bodies. Point number 7. Electrostatic force between two charged particles is independent of presence of other charges. If many charges are present at one place, suppose many charges Q1, Q2, Q3, Q4, Q0, Q5, many charges are here, all are present here. I want to find the force between Q1 and Q3. It only depends on their magnitude, their medium between them, and the distance of separation. So these charges have no role for the force between Q1 and Q3. So this is one point I am telling you. The electrostatic force between two charged particles is independent of presence of other charges nearby. And I am going to the last point of this, point number 8. That's very important, called as superposition principle. This is very important. All the numericals, complicated numericals of Coulomb's law are based on this principle, superposition principle. You have already read it also class 11th in gravitational force. What is superposition principle? If a number of charges present, same thing. If a number of charges present at one place, suppose Q0, Q1, Q2, Q3, Q4, Q5, number of charges are present. I want to find the force on this Q0. How much force can this Q0 experience? Force on Q0. I wrote F0 here. How much force on the Q0 acts? So Q1 apply the force, Q2 apply the force on Q0, Q3 apply the force, Q4 apply the force, Q5 apply the force. All apply the force on Q0. How I will find the total force on Q0? I will find individual forces. Individual forces I will find. After finding individual forces, using Coulomb's law you will find individual forces. After finding individual forces, you will add the forces. How? Algebraically or vectorically? You have to add them vectorically, because just before I told you force is a vector quantity. So you just find the magnitude of forces, show their directions by arrow, see the angle between the forces, then add the forces vectorically. So what is the statement of superposition principle? When a number of charges are present nearby, behave independent of each other, the net force on any charge is equal to vector sum of forces due to individual charges. So this is the statement of superposition principle. So F0 is equal to, who apply the force? 1 apply the force, 2 apply the force, Here 5 apply the force. All the forces you will write independently, individually you will write the forces, see their directions by arrow and do the vector sum. Many numericals will be based on this superposition principle. You can try the numericals based on this superposition principle. It is in book, in examples, in exercise, numericals are there. So this is about the Coulomb's law I explained today to you, and I will giving you some questions. You can do some questions. You can try from the book from first chapter, example 4.1, 5.1, 6.1, 7.1. Now you can do these 4 examples from a book. Also exercise question you can try. Question number 1, 2, 3, 6. These are the exercise questions based on this Coulomb's law. I hope you will complete your questions. So then in the next video we'll explain about electric field. Thank you.